So, hello everyone, my name's Quentin, and this is my absolute basic overview of Ansible. Ansible is free software for deploying and managing systems, remote systems, servers, machines, and this is not really a general tutorial. You can find lots of those online. The idea here is to give you a real simple overview of it so that if someone says, oh, let me show you my Ansible setup, you're not completely baffled by all these files they're showing you. Or if people start talking about it at the pub, you can at least picture what Ansible looks like. So let's get started. What do you need to do things with Ansible? Well, the first thing you need is an inventory. Now, an inventory is a list of the machines you want to do things to, and it can be as simple as a text file. So here's my imaginatively named text file called inventory, and it just contains the names of my servers. You can also create groups of machines in your inventory. So here I've created a group called database, and I've just got one machine in it here. But you can have multiple groups with multiple machines in each, and in fact you can put machines into several groups. So if you wanted to say that DB1 was also a memcache server, you might have a memcache group, and you would just repeat the db1.mycompany.com line inside that group as well. So you can put a server in multiple times in the same inventory. Then if you actually want to do things to those machines in your inventory, you can do a simple command line command like using this Ansible command line tool. These are known as ad hoc commands, where you're essentially just doing one command on one or more machines. So what have we got here? We run Ansible. We specify the machines that this is going to run on. There are various things you can put here. You can put the word all, which means everything in my inventory, or a group, or there are various other ways of specifying subsets of your machines. But I'm going to do this to the machines in the database group. Where is my inventory? That's with the -i option. And this is an Ansible module that I'm running here. So I'm going to use the very simple sort of demo module called ping. So what this does is it goes out, connects to that server, runs a command on it, which gives back the response pong here. What we're seeing down here is a nice kind of somewhat human readable form of the result that comes back from the module underneath. So we talk to the machine db1.mycompany.com. It was a successful thing. We got back from our ping query, we got back pong, and this line is actually quite important. Changed false. This says that nothing changed on the server as a result of doing this. If this had been a command that did something more interesting, there might well have been a change there, and we'll come back to why that's important in a little while. Here's a slightly more complicated command. Again, we're just doing this to the database servers in our inventory, and we're using the apt module here, which installs packages on Debian type Linux servers, and we're giving it some arguments. So we're specifying here the name of the package we want to install, MySQL server, and the fact that we want it to be present. So Ansible is a declarative system. You don't actually say install MySQL server. You'll say I want MySQL server to be installed. If it already is installed, Ansible will do nothing. If it is not installed, it will go away and install it. So Ansible commands are essentially idempotent. You can run them multiple times, and probably the first time they may do something, and if you do it again, in theory, they should do nothing. Not all of them work like that, but that's the basic idea. That it's very efficient because it doesn't do things if the things don't need doing. Here you can see again we've got changed as true. I'm assuming on this particular machine that MySQL Server wasn't installed before we started, and it is now, and you might get back some other information like what comes out of the standard output and standard error stream for that particular command. What you get here will depend on the module, the command that you're running. There are many hundreds, well, certainly dozens, it feels like hundreds of these commands, these modules, to do all sorts of things, from installing packages to checking the version of your operating system, to making sure that a particular line exists in a particular file, to provisioning Amazon EC2 servers, to you name it. If you're likely to want to do it on your server, there's a good chance that someone has written a module that will do it for you. So you very seldom actually have to go and write code that says, run this command on the command line. But there is a command module which will let you do that if you want to. Now, most tutorials start with this Ansible command, but once you've seen it in the tutorial, you may well never use it again. We'll go on to a more powerful version in a moment, but it is worth noting that this on its own is actually quite a powerful command, because if you had 1,000 machines in your inventory, this would actually go and make sure that MySQL Server was installed on all of them for you, and would do so pretty efficiently. One thing I have not shown yet in any of these commands is user authentication, authorization. I am assuming for the purposes of this overview that you have permission to log into, to SSH into the machines in your inventory, and that is all set up behind the scenes. There are ways you can specify it as part of the Ansible command if you need to. That makes it all a lot more messy, so I'm just assuming that yes, you've got your SSH system set up so that you can log in, because Ansible uses SSH. Nothing else needs to be installed really on the machine that's at the receiving end. You don't have to run special agents or anything on the servers to be able to talk to them over Ansible. It's one of its big advantages. Usually if you start up a reasonably bare machine, as long as it's listening on SSH, you can bootstrap it from there using Ansible. Okay, suppose we do want to do something more interesting than just run a single command on the machine. Then we need a thing called a playbook. So a playbook is described in a YAML file. If you haven't seen YAML before, it's just a structured way of presenting some text. It's actually very comparable to a JSON file. It's just a bit more human readable. So here we have a playbook called playbook.yaml, and we're specifying here a set of tasks to be performed on all hosts and a set of tasks to be performed on the database hosts. On all of our hosts, we want to again use the apt module that we saw before, but we're going to do something slightly different here with different arguments. We're basically going to do apt-get update. This is go and find out the latest version of all the packages that might be available to you. As an aside, the apt module has this nice thing which says only go and do it if the if apt-get update hasn't been done within a given period. I'm saying if I haven't done it in the last 10 hours here. That speeds things up quite a lot. So I do that on all of my hosts, and then maybe on the database hosts I say check that the MySQL server is present, and then copy this file onto this destination using the template module. Now template uses by default the Ginger 2 templating system, and so this is a template file on my local machine that's being copied to the remote machine, possibly with variable substitutions and other things being done in the process. It's a very simple example of a playbook, but the way you would run it is to say Ansible playbook -i inventory as we had before, and the name of the playbook, which is playbook.yaml. You don't need to specify now the names of the hosts or the group that we want this to operate on, because we specify that as part of the playbook. Now, this is a very simple playbook, but there is one convention I haven't shown here which I strongly recommend you follow, which is normally you give each task a name field here, which is just a human readable comment that says what's happening. In this case it's very simple, but one of the nice things about this is that the names are printed out as the tasks are executing when you run a playbook like this, and it makes a very pretty output, and it's also a very good way of documenting what's going on. As an aside, a nice thing about Ansible playbooks is that if you just grep them for name : you actually get a remarkably readable list of the operations that need to be done. It's almost documentation in itself. Again, most of these tasks are idempotent, so in theory you run this playbook once and maybe some things happen, you run it again, and in general they shouldn't, because nothing will have changed, nothing needs to be changed as a result of running the playbook the second time. Okay, let's make our playbook slightly more sophisticated. We can put variables in here. So within a particular play, this is a play in my playbook, you can specify some variables, like a fixture name here. This might be a SQL file I want to copy across. So here I'm using the copy module to copy that fixture, the file name fixture name, into /dump/fixture name on the other end. Presumably from there I'm going to install that SQL file into my database or something. So we can put variables in here, and we can use actually Ginger templating constructs in the playbooks as well. and which makes them quite powerful. We can do simple loops. So for example here I'm using the with items clause on a particular task. I'm giving it a list of things, in this case apt packages, and I'm saying install this item. This is just the same apt command we had before. It's just in this one task we will now install 3 different packages without having to write 3 different apt commands down. So you can do that, and we just put the list of packages in there. And we can combine this with the variables we saw earlier. Our last example of a variable was just a simple string, but variables can actually be structured. They can be lists here. So here's a variable called packages, which is the list of packages I want installed. And then in my task, I can just say with item packages, and it will use that variable and go through and make sure everyone is installed. So that's quite nice. You get all your variables out of the way at the beginning of the playbook, but often you wouldn't actually want them in the playbook. You'd want them factored out somewhere else in a separate file or something. So how would we do that? Let's take a look at some of the conventions for laying out your Ansible projects. Here's my directory structure. So we have the inventory that we had before. We have a playbook. I'm calling this deploy.yaml. I'm deploying stuff to my servers now. You can call them what you like. But there are some things that have traditional names which Ansible does pick up. So if you have a directory called group_vars, then variables that are defined in the files within this will be applied to the machines in those groups. So you can create a file called all, you can create a file called database. Any variables you define in database, for example, like the list of packages you want installed, would then be in scope when you run this this playbook here, and so they would be defined for your database servers. You can also do it for individual hosts, so if you want to set something specific on server1.mycompany.com, you can create a host vars directory. Again, you just run the thing in the same way. You don't need to say that those are there, because host vars and group vars are standard directories that Ansible will look for. Now, the inventory here we've had up to now has just been a simple text file, and it can also be an executable file. So imagine you have a script that goes out and finds all of the servers that you have on Amazon's AWS system or on a DigitalOcean account or something like that. That saves you having to keep a list of them. It can do it as a script. It returns it in a particular format, and Ansible will then pick it up automatically. As you create new hosts, they will automatically be included. There are standard scripts for many of these systems that come with Ansible, or that you can get from the ansible.com site. So it can be an executable script. It can also be a directory. Let's see what that might look like. So here I'm specifying that the inventory I want to use is staging, and staging is now a directory. So what Ansible will do is it'll look through that directory, and any text files that it finds in there, it will look inside just as it did before for host names and group names. Actually, if there are any executable files in here, it will execute those in the same way. So you can make an interesting combinations of ways of building up your inventory. And it will also look within that inventory directory for group and host variables. And so here, for example, I've got a staging inventory, and I've got a live inventory for my production world, and I may have different variables, different settings defined. I may have debugging turned on in here and not in here, and so on. And this is a very nice way of separating potentially very large amounts of information that are essentially configuration information for particular groups of machines. So when I want to deploy to my staging server, I do -i staging. When I want to deploy to my live production server, I do -i live there. And that's a nice way of, that's how I quite typically will group my inventory directories. So this makes the inventories more sophisticated. What about the playbooks? Well, Ansible has a thing called roles. Beforehand in our playbooks, we just had a list of tasks that should be performed, and that's great, that works fine, but after a while your playbooks can get really quite large and unwieldy, so we need a way to break things down into modules, and the way Ansible does that is through roles. So a role is a way of grouping together a set of functionality, playbooks, templates, default variable values, and so on in a convenient module in a directory, essentially. And then the way you use those in your playbook is simply to tell Ansible that particular machines or groups of machines should have particular roles. So imagine we have a common role that contains perhaps the packages that we want installed on all of our machines, and then separate roles which describe how we set up our web servers and how we set up our MySQL servers. And this little playlist here makes sure that both our web servers and our database servers have the common role, but then they have separate roles after that. Let's see what that would look like in our directory structure. Well, what you do is you add a roles directory, and underneath it you put a subdirectory for each role you want to create. Again, we still run it in exactly the same way as we did before. Let's have a look at what's inside one of those roles directories. Well, there are several things you can put inside here. The first thing you probably want is tasks main.yaml, and that is just a set of tasks as we had in the playbook before, saying these are the packages I want to install, these are the files I want to copy, and so on. But you can also create a defaults directory and put in various default variable values, which might then be later overridden with more specific examples in the inventory. So we can put in variables and tasks to execute. Some other things we might have in here are files, perhaps, that are going to be copied, standard files that are part of the common role that we want on our servers, templates that we might want to copy across using the template module, doing some substitution on the way, and so on. So these are the kind of things, there are others, but these are the kind of things that you can package up into a role and just say, this is my common role, I want this stuff to happen on all of my servers. And if you design these well, it turns out that these roles can be remarkably reusable. I often find that I can take a database role that I've used in one project and copy it almost unchanged, typically, into another project, perhaps just tweaking the variables in the inventory. In fact, they're so reusable that you can publish your roles online if you want to on the Ansible hub, and you will often find that many people have done this, and if there's some particular job you want one of your machines to perform, it's often worth looking on the Ansible hub first and seeing whether somebody has already published a role that does that or something very close to what you want to do before. It can be a great source of inspiration even if you don't actually use what they've done directly. Now, you can also specify dependencies within roles. So here, for example, imagine that I have several roles, common, database, and Unix uWSGI, and I know that whenever I set up a web server, I at least want to have the common and Unix and uWSGI roles installed as well. It seems silly to have to repeat that in my playbook. So what you can do is within a role you can create a meta directory which can contain various things under its main.yaml, but including the dependencies. You're saying this web server role is dependent on these other roles, and now rather than having to specify in our playbook the list of the roles that we want on our web servers, we can, and the list of the roles we want on our database servers, we can actually just say I want my web servers to have the web server role, I want my database servers to have the database role, and everything else is neatly packaged up. All of those dependencies are known about in the roles themselves. So there you are. That's where I'm going to stop. That is a rather strange tutorial of Ansible, but you have learned quite a lot already. You know that Ansible has an inventory, a list of the machines on which you want to do things. It has a large number of modules which can do all sorts of things on your servers for you, and a command module if you want to actually just write shell commands or similar things yourself. It has playbooks, which are essentially a list of instructions that you want to be executed on various groups of machines in your inventory using those modules, and you can package chunks of functionality up into roles so that you can describe in a more generic way the roles that a particular server should hold or a particular group of servers should hold. So I hope that's been useful. You can find lots more stuff on Ansible.com or by searching for Ansible tutorials online, but I hope that gives you a general overview of what Ansible looks like and the kind of things it can do. It's a wonderful system. I do recommend it. I've used various other systems, but Ansible has become our favorite, and it can look a little eccentric when you first see it, but I hope that's started to give you a feel for what it looks like.